Hello everyone. My name is Jamil and I'm from the Triangle Group. And I'm here today with my classmates Manan Doshi and Rahul Soni. And we're guided by Professor Soni Bambar ma'am. And we're here to give a demonstration of our final year project Adore, which is aimed for personalizing salon experiences using machine learning and image processing. So uh, how the entire system works is we require two input images from our users. So one is the front facing image and one is a photo of their head taken from the hair side, so that we can get maximum hair and analyze it for generating the haircut recommendations. So after we get those two input images, our first task is to perform semantic segmentation of the image. Now, there are a lot of approaches that have been designed for segmentation of the images, but the approach that we went forward with was an implementation of a neural network architecture called BiSnet that was trained to parse the facial images. Now, there are a certain reasons as to why we preferred BiSnet, but two of the major important reasons were speed and the accuracy that BiSnet provided as compared to all the other state-of-the-art deep learning models that were designed for the semantic segmentation task. So as we can see on the screen, this is an illustration of what we mean when we say image segmentation. So from both of these images, we want to filter out or crop the hair segments and the face segments as well. So assuming that we have two input images from the user, I'll show you how the output from the BiSnet network looks like. Yeah, so given this original image, starting from the leftmost side, we have the original input image. Then we have the cropped skin, the cropped hair, the skin mask, and the binary hair mask. Now, after we have this, so from the front facing image, we're taking out the face mask, and from the rear image, we're taking the hair mask. Now, from the hair mask, we also extract a 227 by 227 patch of hair that we pass to a ResNet 50 classifier, and we use that ResNet 50 hair classifier to determine the hair texture. Hair texture is an important feature for hairstyle recommendation, and how it affects the recommendation we'll talk about in the later part of the video. So with our ResNet 50 classifier, we observed a testing accuracy of 71%. So I'll show you the result from the ResNet 50 classifier. Yeah, so the second image shows the hair mask that was obtained by the BiSnet network. Then from that, we have a 227 by 227 hair patch. And when we pass it on to the ResNet 50 classifier, it gives us two hair textures, two prominent hair textures that it identified in the image, that is deadlock as well as straight. Now, the next feature that we identify from the front facing image is the face shape. So the face shape can be any one of heart, round, oblong, oval, and so on and so forth. So there were three approaches that we tried to determine the face shape, and the approach that worked best for us was to determine 15 horizontal lengths of the face and 15 vertical lengths of the face. And after that, we pass it to a supervised machine learning classifier, which helps us determine the face shape. So the machine learning classifier or the algorithm that gave us the best results was light GBM, which stands for light gradient boosted model. So as from the image that we can see, the input image, the LGBM classifier predicts that the image has a hard face shape. Now the remaining features, I like my colleague Rahul Soni to explain.
Yeah, thanks, Jamil. Going on to the next feature that we try to find is the skin tone. Skin tone becomes another important feature while recommending hairstyle because it helps in determining the placement, saturation, and the undertones in the skin that would like to emphasize. So for this, we tried three methods. One is to find the mean RGB values of all the pixels lying in the skin region of the segmented picture. Secondly, applying the similar technique but using HSV. And third method that we tried was using the k-means clustering algorithm with k equal to 4 to group similar pixels and to identify the most dominant colors from the face mask. This model was trained on 100 Indian celebrities. Moving on to the next feature that we found was the hair color. To get the hair color, a very similar technique was used, but instead of applying K-means clustering on the face region, it was applied on the hair region. So this were the two. Through this, we identified the four dominant colors from both the masks, the hair mask and the face masks, and we classified the skin tone into dark, medium, and fair skin tone, and the hair color into blonde, gray, and black. Moving on to the next important characters while recommending or deciding what hairstyle to give comes the age and gender. They become important because a major impact on selecting the hairstyle, because a funky hairstyle on an 18-year teenage would gain quicker looks in a public, whereas the same hairstyle for a 50-year-old man would not go well, even if they have the same characteristics. So for this, we've used a pre-trained implementation of a mobile net model, which is a multi-output CNN method model to solve sub-problems on an ordinal regression problem of age estimation. So the output of this step is the age and the gender of the sample. So as you can see from the left to the right, the first image is the original image, followed by which followed by which a black and white image, which is passed to the model. And the third image is the landmark used to estimate the age, and finally the output, which is the gender, and the age is mentioned as above. Yeah. Moving on to the recommendation part, I would like to Manan to continue forward.
Thank you, Rahul. So this section covers the first phase of Adore, which is feature extraction, where we extract 4 important features for hairstyle recommendation. Now we have packed this entire process into one command line utility or an API, so that given any 2 images, we can run the entire process over it. That is first feature extraction and then hairstyle recommendation. Now, just to give a small demonstration for that. Yeah. So let's say we have these 2 input images, that is one a front facing photo and a side or back facing photo. Now we run our entire utility over this for, yeah. So by the time the process runs over these 2 images, let's walk through how the hairstyle recommender actually works. So yeah, up till now we have seen feature extraction, that is age and gender, face shape and skin tone, hair texture and the hair color. So these are the 6 major features extracted for the given input image. Now the next step for hairstyle recommendation. Now hairstyle consists of 2 major parts, one a haircut and second the hair color. These are the 12 haircuts that we have chosen. These are standard haircuts for men, and we recommend from these 12 haircuts. Similarly, we have picked 8 hair colors from which recommendations are given. Now, depending on the face shape, we decide that which hairstyle suits a particular face shape. So a blue box indicates that yes, an oblong face shape can have a buzz cut, while a yellow box indicates that an oblong face shape cannot have crew cut and fade. As we can see, the oval face shape allows for all the hairstyles because it is the best face shape. Similarly, depending on the hair texture, that is straight, wavy, or curly, we recommend we recommend the 12 hairstyles. So again, we prepared if-else rules for that. So this shows the output filtered by the heart face shape and a straight hair texture. So the ones which are highlighted are the hairstyles which would be recommended to the individual. Now we've used face shape and hair texture. Now we make use of the skin tone and the hair color to determine what hair color suits an individual. So again, if-else rules are prepared for that. And the final filtered result for a medium complexion person with black hair is as follows, where the dark neutral blonde and green color does not suit that male person. So these are some of the style blocks that we've referred for developing this recommender system. These are tips and insights given by stylists which have been working in the industry for a very long time. So this covers the hairstyle recommender. Let's go back and check whether, yeah, so our process is still running. But if we see the folder now, apart from the two images, we have a lot of other intermediate images. So as we can see, we have the masks shown here. So we have the skin mask here, we have the hair mask here, we have the complete face mask here. And this is the cropped hair texture, the 227 by 227 cropped hair texture we were talking about. This is what will be given as input so that we can find out the hair texture. What we can also see are the 15 markers for identifying the face shape. Currently, the process that is running is for age and gender estimation. Then depending on the gender, one of the two recommenders will be called a male recommender or a female hairstyle recommender. So as we can see at the end of the phase 1, which was feature extraction, we get 6 features extracted. That is, hair texture is straight, face shape is heart, hair color is black, skin tone is medium, gender is male, and age estimated is 47. Now, based on these features, we run our hairstyle recommender. I just walked through in the PPT and prepare a style guide. Yeah, so this is a personalized style guide that we prepared based on the features, where the hairstyles that are recommended get highlighted and the others are faded. Similarly, for the hair color, we show colors that will best suit that individual. Now, apart from that, apart from suggesting hairstyles, we also suggest certain do's and don'ts for a particular feature. Say for a heart face shape, what type of hairstyle works and what does not. So some additional styling tips are also provided for face shape, for hair texture, for the hair color, and finally skin tone. This completes the style guide that we offer as an end result of our solution, which starts with taking just 2 input images, extracting all the features, and generating a style guide for recommended hairstyles as an output. And that's it from our end. Thank you.